In this video, we will be discussing unit rates. Our objective for this lesson is to A, be able to compute unit rates, and then B, to determine the most efficient rate, whether that be a better buy, the fastest speed, or something along those lines. Before we talk about unit rates, let's define the word rate. A rate is a ratio between two related quantities. Common examples that we have of rates are things relating to speed, such as miles per hour, feet per second. Those are our most common types of rates, and those are rates per unit time. Rates can also be used to talk about rhythms or frequencies, such as our heartbeat, sometimes called our heart rate. A patient may have a heart rate of 60 beats per minute. Tax rates are the amount of money allotted per price of something or per income. Those are other examples of rates. What then is a unit rate? Well, by definition, a unit rate is a rate expressed as a quantity of one. In all of my examples I just gave, where I may have said 55 miles per hour, that is a unit rate because it has a quantity of 1 hour. But we could also talk about rates that would be 2 feet per 3 seconds, or 100 pounds per 3 bags. If we wanted to convert those to unit rates, we would have per 1 bag, or per 1 second, or per 1 hour. Here are some examples. A car may travel 300 miles in 6 hours. We would say the rate is 300 miles per 6 hours. This dividing line that makes our rate look like a fraction also means per. That's why we can say this says 300 miles per 6 hours. If we wanted to convert this rate to a unit rate, all we would do is we would simply divide our numerator by our denominator. The denominator would go on the outside, and our numerator on the inside. If you prefer, you could say top goes on the inside, bottom goes on the outside. So to compute this as a unit rate, I would divide 6 into 300, and I would get 50. And now my unit rate is 50 miles per hour. Keep in mind our definition of unit rates is expressed as a quantity of 1. Notice there's no number in front of the word hour. That's an understood 1 hour. Here's one for you to try. In a package of toilet paper, you have 3 rolls and 1,060 sheets of toilet paper on those 3 rolls. Find the rate and then find the unit rate. The rate would be 1,060 sheets per 3 rolls. Now, do you remember how to find the unit rate? If so, push pause and do so. To find the unit rate, remember that we take our numerator and divide it by our denominator. So in this case, we would have 1,060 divided by 3. And when we do our division, we get 353.53, and the 53 would repeat. For the sake of this example, we're just going to use 353. And we will say that our unit rate equals 353 sheets per roll. Now it's very important that you notice that I have listed units in both examples, whether it be miles per hour or sheets per roll. We don't want to just give a number. We want to make sure that we are including our units so we'll know what the relationship between our two quantities are. Okay, let's have a little bit more fun with this example. Let's listen to the flash here in this video.
Alright, Superman, I'm serious. I can run around the world 3 times in less than 2 minutes. You just gotta believe me. Alright, fine, Flash. If you think that you can run around the world 3 times in less than 2 minutes, then show me. Alright then, Superman, I would.
Okay, so Lego Flash says he can run around the world 3 times in 2 minutes. So here we have, I've written it down for you. Flash says he can run around the world 3 times in 2 minutes. Do 2 things. 1, find the rate, and then 2, find the unit rate. I hope this is what you put for the rate. The rate would be around the world 3 times per 2 minutes. Now let's find the unit rate. We will take 3 divided by 2, and we'll get 1.5. So the unit rate is around the world 1.5. Let's erase that and make that a little bit neater. 1.5 times per minute. This is a unit rate because we have a quantity of 1 in our denominator. The other thing that I want to make note of is the fact that there's a decimal in this rate. When we're doing rates, it's okay to have decimals in here because these aren't necessarily fractions. They are a comparison of related quantities, but they have a different nuance than, say, fractions would. So this is okay to have a fraction in your unit rate. We're going to shift gears here for just a moment. We're going to actually go into a grocery store. We're going to look at several different products and see which one is the better buy. Okay, here's our first example of a bonus buy. Here's a 3-pound bag of Red Delicious apples for $3.99. But down here is a 5-pound bag of Red Delicious apples for $5.99. Which is the better buy? In order to find the better buy, we had to look at our 2 options. Option 1, we had $3.99 for 3 pounds. Option 2 was $5.99 for 5 pounds. Now note that when we're trying to find better buy, we are always putting our money on top because we're looking for money per 1 unit, price per unit. Okay, so dollars per pounds or dollars per ounces or pennies per ounces, depending upon how it's measured. To find the unit rate for option 1, we're going to say $3.99 divided by 3, and we will get $1.33 per pound. For option 2, we'll say $5.99 divided by 5, and we will get $1.20, I round to the nearest penny, per pound. The way to decide which is the better buy is whichever one is cheapest per pound. And option 2 is the cheapest per pound, $1.20. So that is the better buy. Let's look at another example. Okay, here's example number 2. We're looking at Harris Teeter brand real mayonnaise. Here's a 12-ounce tube for $2.49. And down here we have a 30-ounce jar for $2.97. Which is the better buy? Let's look at our two options more closely to determine our better buy. Option 1. For $2.49, we could get 12 ounces. In option 2, for $2.97, we can get 30 ounces. Now in this situation, you can probably look at these numbers and see that option 2 is probably going to be the better buy. But let's go ahead and do the math to prove it. Let's do the unit rate for option 1. $2.49 divided by 12 is 0.2075 cents, or 20 3/4 cents per ounce. Now we should probably go ahead and round that to 21 cents per ounce. Let's look at option number 2 now. We take $2.97, we divide it by 30, and we get 9.099 cents per ounce. We'll round that off to 10 cents per ounce. Okay, so option 2 is the better buy, and in fact it's over half the cost, less than half the cost rather, of the other option. Here's one for you to try on your own. Okay, here's example 3 for you to try on your own. Here's a jar of Ragu spaghetti sauce, 24 ounces for $2.19, or for $3.59, 46 ounces. Which one is the better buy? Try this one on your own before you proceed. If you need to go back and replay to find the prices because they were said too quickly, then go right ahead, but be sure to do the problem on your own before you look at the answer. Let's look at our options. One option was a 46-ounce jar. The 46-ounce jar was $3.59 for 46 ounces. The second option was a 24-ounce jar, and it was $2.19 for a 24-ounce jar. If we compute the unit rates for each one of these, $3.59 divided by 46, we would get, round it to the nearest penny, 8 cents per ounce. We do the 24-ounce option, $2.19 divided by 24, and we get, to the nearest penny, 9 cents per ounce. So in this case, it's option 1, the bigger jar was the better buy. Now just a word of caution here. The larger size is not always going to be the better buy. In most cases it will in a real life scenario. But when doing these problems, don't automatically assume the bigger jar, the bigger bottle, the bigger package will give you the better buy. It just so happens that in all of our examples so far from the grocery store, that has worked out in that manner. There are the occasional times where the larger size is not the better buy, which is why it's always important to do the math. Now let's move on to one last example for you to do on your own. Finally, try this last example and determine the better buy. Here's the final example for you to try yourself. Microwave popcorn, Orville Redenbacher's light butter, 12 bags for $4.69, or Pop Secret, 3 bags for $2.75. Which is the better buy? Looking at our final set of examples. Option 1, we had a large box of Orville Redenbacher, $6.69 for 12 packs of popcorn. The other option was Pop Secret, and that was $2.75 for 3 packs. When we compute the unit price, $6.69 divided by 12, we will get that the Orville Redenbacher is, to the nearest penny, 56 cents per pack. And the Pop Secret, to the nearest penny, will be, we take $2.75 divided by 3, we will get, to the nearest penny, 92 cents per pack. So option 1, again the larger case, the larger size, turned out to be the better buy. So in summary, a rate is a comparison of two related quantities. A unit rate is a rate whose unit is 1, and we can use that idea particularly in our shopping to determine the better buy by looking for the lowest unit rate and therefore having us spend the least amount of money and getting a better buy.